Hello, students of science. Let's talk about limiting reactants and percent yield. In most reactions, you're going to have an excess of one reactant and you're going to have a limited amount of the other. It's pretty much impossible to make sure that they are both used up evenly. It's not going to happen. So let's take a look at this example of trying to make cheeseburgers. These are going to be my reactants, what I start with, and these are going to be the products. These are going to be the things that I'm trying to make. That means that these right here are going to be my excess reactant. The thing that I ran out of first was the hamburger patties. I had extra cheese, I had extra tomato, and I had extra buns. My limiting reactant was the hamburger patty itself. So here I can see the concept of, oh, I ran out of these first, but I still had some of those left. The limiting reactant, in this case the hamburger patties, is completely used up first, and that limits the amount of products. Having only 3 hamburger patties means I can only make 3 hamburgers using this formula right here. It doesn't matter if I have 10,000 slices of cheese or 1,000,000 tomatoes or all the bread in the world. I'm limited to 3 hamburgers because I only have 3 hamburger patties. We would say it limits my reaction. It's like if you're making a sandwich, you don't have ham for your sandwich, that's your limiting reactant, not the stuff that you have a lot of. The way to figure out what is the limiting reactant is to just pick a product. It doesn't really matter which, just stick with it. So just stick with one product here. So in this case right here, I am making a hot dog. So obviously I have the hot dog itself and the hot dog bun. Let's calculate how many products each of my reactants could make. Well, here I have enough for 5 complete hot dogs, and here I have enough hot dog buns for 4 hot dogs. So obviously, which one of these is going to limit it? It's going to be the hot dog buns. So this one is going to make the fewest products, and therefore is my limiting reactant. The other reactants we would say are my excess reactants. So here's what I'm going to have: 4 complete hot dogs and 1 excess leftover one. So I looked at the product, a complete hot dog with bun, and I see I ran out of hot dog buns first. That is my limiting reactant. Let's look at another theoretical example. Here the formula is a frame plus 2 tires makes a bicycle. There's other parts, but we'll ignore those for now. Now here I have 7 tires and 5 frames. You might think that the frames are the limiting reactant because I only have 5 of those, whereas I had more than that for the number of tires. But I have to look at this ratio in there. 7 tires is enough for 3 bicycles, plus 1 left over, but we're not making unicycles here. 5 frames is enough for 5 bicycles. Here I'm looking almost at that molar ratio. 1 frame to 1 bicycle, 2 tires to 1 bicycle. So you have to go through that and see, oh, 5 frames, 5 bikes. 7 tires, that's enough for 3.5 bicycles, but we're obviously not going into half a bicycle here. So my limiting reactant is going to be the tires, because I can only make 3 bicycles as opposed to 5 bicycles with the frames. So limiting reactant here is tires. Let's look at a natural example. Zinc and sulfur react to form zinc sulfide according to this equation. 8 zinc plus 1 sulfur, in this case there's 8 sulfur in one of these molecules, is going to react to form zinc sulfide, but here I have it balanced out of coefficients of 8, 1, and 8. Now the question is, 10 moles of zinc is going to react with 2.5 moles of sulfur. What's the limiting reactant? You can't just go by, oh, I got 10 moles of zinc and 2.5 moles of sulfur, therefore sulfur is limiting. I can't go by that. I need to look at the products to figure out which one's going to run out first. 10 moles of zinc is going to make 10 moles of zinc sulfide. I use the molar ratio of 8 to 8 there, so it's essentially multiplying it by 1. However, 2.5 moles of sulfur is enough to make 20 moles of zinc sulfide, because in this case right here, for every 1 mole of sulfur, I'm going to get 8 moles of zinc sulfide. So I have a ratio of 1 to 8. In that case right here, I can see clearly my zinc is the limiting reactant. I ran out of that one after I made only 10 moles, whereas I have enough sulfur to make 20 moles. Whichever one makes less is my limiting reactant. In that case, it's the zinc. So my sulfur is going to be excess, zinc is limiting. Let's look at another one. Hydrogen and oxygen. I have 10 moles of hydrogen and 7 moles of oxygen. I can't just go by those numbers. I need my equation. In that case, it's 2 hydrogen plus 1 oxygen is going to make 2 moles of water. Well, let's take a look. 10 moles of hydrogen and 7 moles of oxygen. 10 moles of hydrogen is going to make 10 moles of water, because I looked at this relationship here. 2 to 2, so I'm multiplying it by 2 over 2, or 1. 7 moles of oxygen is enough to make 14 molecules of water, because right here I have a relationship of 1 to 2. I'm multiplying it by 2. Well, which one of these is limiting? This one makes 10, this one makes 14. Therefore, this one is less. Hydrogen is my limiting reactant. So if I'm to look at this, even after everything reacts as much as it can, I still have oxygen left over. Oxygen was excess, hydrogen was my limiting. Now, we should look at something called actual and theoretical yield and percent efficiency. Now, no equation is perfect and no equation goes to completion. There's always going to be a little bit left over. Think of it as when you're baking a cake. You're never going to make everything that you put in there. There's always going to be some stuff to the beaters, some stuff to the pan, some stuff to the bowl. You're going to lose a little bit. Theoretical yield is the maximum amount that could possibly be made. The best cook, the best chemist in the world could not get higher than theoretical. Actual yield is how much as actually measured. After you've lost things, you dropped an egg, some of it was stuck to the pan, some of it was stuck to the fork, you couldn't get it off. You calculate the percent yield by doing the actual divided by the theoretical times 100. So let's say I have a theoretical yield of 4 hot dogs, because remember, I ran out of the hot dog buns first. However, your actual yield was only 3 hot dogs. Maybe one of them, I don't know, got eaten by a very hungry cook. So we would say my actual yield was only 3 hot dogs. I lost a little bit in there. 3 hot dogs divided by 4 hot dogs times 100% is going to give me a theoretical yield of 75%. I was 75% efficient at making hot dogs. That's pretty terrible considering how easy hot dogs are to make, but I digress. So let's look at an example of percent efficiency. Methanol is produced via the reaction carbon monoxide plus hydrogen gas makes methanol. If I have 75 grams of carbon monoxide react with an excess of hydrogen, so that is definitely not my limiting reactant, 75 grams of this, and it's going to produce 68.4 grams of methanol. So don't worry where that number came from, that's just going to be given to you. That's saying, here's how much we actually got. We need to calculate how much we could have theoretically gotten. So my actual yield is going to be 68.4. I'm going to divide that by what I could have gotten. So to figure out what I could have gotten, I'm going to take 75 grams of carbon monoxide. That works out to 2.67 moles of carbon monoxide. Now, for every 1 mole of carbon monoxide, I have 1 mole of methanol. So that's going to work out to be 2.67 moles of methanol because I have a 1-to-1 molar ratio. 2.67 moles of methanol works out to be 85.79 grams of methanol. So my theoretical yield is going to be 85.79. Remember, to calculate, actual divided by theoretical times 100. So I'm going to do 68.4 divided by 85.79 times 100% is going to give me 79.7% efficiency. I obviously am a better chemist here than I was at making hot dogs, because here I got almost 80% of what I could have out of my reaction. So start with what I actually did make and divide that by what I could have made using this calculation right there.